This ancient star is challenging the theory of the Big Bang. The Big Bang theory is a cosmological cornerstone that explains the universe's genesis roughly 13.8 billion years ago. It is one of the most famous ideas ever devised, and it is difficult to refute because it is supported by data like as the cosmic microwave background radiation and Hubble's law. This amazing theory accurately predicts the abundance of light elements such as hydrogen and helium and describes the expanding nature of the universe. Its predictions are also supported by observations of large-scale structures and the redshift of light from galaxies. Challenging the Big Bang theory would cause astronomers and scientists enormous stress and sleepless nights because it would involve the invention of an entirely new theory nearly from scratch. So is there anything that disproves this theory? Some believe Methuselah, an old star, predates the universe itself. Follow me in this video to learn more about this fascinating subject. Hello everyone, welcome back to Z. Subscribe to our channel and ring the bell to receive our daily videos. The universe's age. The scientific community has traditionally placed a high value on dating the Big Bang. Astronomers used observations and scientific calculations to calculate the age of the cosmos. They concentrated on the earliest objects in the universe, which were stars and galaxies. They started by looking for the oldest stars. Stars, like humans, have lives. When a star is born, it begins to shine. However, it ultimately runs out of fuel and stops shining. Astronomers learned how long stars have been in our universe by researching the oldest stars they could discover. Don't worry if you're wondering how they discovered the universe's oldest stars. We'll get back to you as soon as possible and clear up any confusion. Please bear with me for a moment. The problem is that stars alone are insufficient to estimate the true age of the cosmos. So they looked at the radiation from the cosmic microwave background. This appears to be a faint glow that has spread throughout the universe. It's like a snapshot of the universe when it was very young. It is the best source of information for learning about the universe's early days when it was still a baby. But wait, there's more. They were also able to determine the rate at which the universe is expanding. Consider a balloon with a pattern of dots on it. The dots move away from each other as you blow up the balloon. The same thing is happening in the universe. Galaxies are migrating apart. Scientists could estimate when everything began from one location by monitoring this movement through the study of supernovae and looking back in time. Astronomers calculated that the cosmos is approximately 13.8 billion years old after putting all of these components together. This is unfathomably old. This figure is so large that if you lived to 100 years you would have to live, die, and resurrect 138 million times. 13.8 billion years. Based on the information obtained by analyzing stars, galaxies, and the radiation left behind from the Big Bang, this is the best estimate we have. Doesn't it seem impossible for anything to be this old? However, there are stars that are nearly as old as the cosmos. They appeared shortly after the Big Bang. One of these is the renowned Methuselah Star, which might, in theory, call the Big Bang theory into question. However, we must first address a question: how do astronomers determine the age of a star? What does it take to assess its age? The age of the stars. Now I understand that stars are gaseous balls that blaze in the universe, burning elements and combining them into heavier ones as time passes. However, I want you to imagine them as massive cosmic clocks whose precise timekeeping is impossible to determine. How do you tell how long a clock has been ticking? You must be an excellent detective. First and foremost, astronomers examine the star's brightness and color. The universe is teeming with both faint and bright stars. Furthermore, some are reddish, while others are more bluish. It may appear strange, but the hue of a star is closely tied to its age. Blue stars, for example, are frequently connected with children. Older stars are represented by redder stars. To be more specific, scientists employ a Hertzsprung-Russell (HR) diagram, which is similar to a star chart. It organizes them by color and brightness. Astronomers can determine a star's age by comparing its position on this chart to others. It's similar to estimating someone's age by looking at their photo in a crowd. But this is insufficient. Good astronomers aim to develop models that describe the life of a star. They discovered that every star, like every human on Earth, travels through many life stages. There's the protostar, a baby star that evolves into an adult star. Most stars in the cosmos are discovered to be at this stage, and their position on the HR diagram is clearly defined. These stars are known as main sequence stars. They could be described as average stars in the universe. Stars eventually die young or become seniors, such as red giants or white dwarfs. Astronomers can determine the age of a star by determining which stage it is in. Of course, this requires the development of a stellar evolution theory as well as highly good models. Methuselah. The Methuselah Star, also known by the rather dull designation HD 140283, has sparked considerable curiosity and controversy over the years regarding its age assessment. Everything began in 1912, when the first catalog was created. Mount Wilson Observatory astronomers discovered it was only 190 light-years away from Earth. Early estimations claimed that this star could be older than the cosmos itself, which would have been a significant mystery for astrophysicists. They said it could be 1 to 2 billion years older than the Big Bang. A more precise assessment in 2013 using data from our beloved Hubble Space Telescope altered the star's age estimate, which turned out to be 14.46 billion years old. This was startling since it appeared to contradict the accepted age of the universe yet again. Indeed, as previously stated, the cosmos is considered to be 13.8 billion years old. So, how can we account for this disparity? Is the Big Bang Theory likely to be debunked? If you found this video useful, please give it a thumbs up, subscribe, and ring the bell so you don't miss out on any future updates. Uncertainties. It's crucial to remember that determining the age of stars can be a difficult procedure, with many factors such as uncertainty in stellar models and measurements contributing to disparities. In 2013, scientists speculated that Methuselah could be older than the entire cosmos. That's equivalent to suggesting someone is older than their birthday. However, other teams of scientists attempted to guess Methuselah's age and came up with different figures. Some estimated it to be roughly 13.7 billion years old in 2015. Others speculated in 2021 that it could be even younger, at 12 billion years. The real kicker is that even if we assume Methuselah is 14.45 billion years old, there is a margin of error of around 0.8 billion years. This suggests that the star is anywhere between 13.65 and 15.25 billion years old. More specifically, there is a 70% chance that the star's true age falls within that range and a 30% chance that it falls outside of it. This also implies that there is a 15% possibility that HD 140283 is younger than 13.65 billion years. In other words, Methuselah could be both older and younger than previously supposed. Scientists believe it could be younger, which makes sense because a star cannot be older than the party at which it was born. This whole discussion isn't really shaking up the scientific world. It's mostly an issue for people who want to criticize the Big Bang idea. Populations 1, 2, and 3. So where exactly do these uncertainties come from? It is all about the measurements taken from the ground. Remember that we can only determine the age of a star by taking measurements. This entails spending nights at the telescope, attempting to capture the star and viewing it for an extended period of time, while praying that the atmosphere and weather circumstances enable us to do so. However, the weather is merely the beginning of an astronomer's challenges. For example, when studying really old stars, astronomers anticipate them to have very specific characteristics. They anticipate that such stars will be extremely low in metals. This is because, assuming these stars existed, they would have been created in an atmosphere rich in hydrogen and helium but depleted in heavier elements. These stars are known as population 3 stars, but we have never been able to observe one. Even though scientists believe they may still exist somewhere in the universe, discovering them will be difficult. The population of 3 stars, like all other stars, began slowly fusing their components, transforming them into heavier ones. This is how the universe's initial metals were formed. Following then, the population of 2 stars, including Methuselah, consumed and processed these heavier elements. As you can see, the life and death of population 3 and 2 stars gave the cosmos with the crucial components for the construction of stars like our Sun, capable of building planets around them and sustaining life as we know it. These younger stars, which contain a variety of heavy elements, are members of the population 1 star. Determining the age of the population of 2 stars like Methuselah is a difficult process since astronomers rely on measurements of gas absorption lines emitted by heavy elements present in the star's outer layers. If a star has extremely few of these elements, the precision in terms of age decreases and the uncertainties increase. It's like attempting to estimate the size of a house from a great distance. Even if you know the average size of a house, your estimate will be influenced by errors in your measurements because you overlooked small details that were not visible from such a great distance. The importance of more accurate estimates. The narrative of Methuselah emphasizes the need of having up-to-date measurements taken with various tools and methodologies. This is true not only for the age of stars, but also for the age of the universe. In the coming decades, we plan to develop techniques that will allow us to identify extremely faint lines in stars with extremely low heavy element abundances, allowing us to make more accurate predictions for stars like Methuselah. On the other hand, we should never stop challenging the validity of our beliefs because it is the only way for science to progress. That is the only way for us to comprehend the cosmos and ultimately ourselves. Alright guys, this video ends here. Thanks for your time. Do you believe Methuselah might prove the Big Bang Theory wrong? Please let us know in the comments. Don't forget to subscribe and I'll see you on the channel again soon.